This worksheet is labeled the Chapter 1 Quiz 2. It's a quiz that we did in class. However, people didn't do all that well on it, so I wanted to give them more practice. So that's why it says quiz. And the purpose of this quiz was to get some more practice in doing mental math. And so it works primarily with the commutative, associative, and distributive properties. Remember, the commutative property says that you can put things in any order that are only being added or only being multiplied. The associative property says you can group them in parentheses if it's only being multiplied or added in any way that you want. And then the distributive property says that if you have a number outside the parentheses, it gets multiplied by all things inside. So in problem number 1, remember it says show all your work to get full credit, so all the work that I'm showing would be expected for you to get credit on this as well. In number 1, it's going to be a distributive property problem. We're going to think about 709 in a little bit different way, and there's several ways that you could do this. One way would be to say that 709 was 700 plus 9. And then what the distributive property does is it takes 4 times 700 and then keeps the symbol in between, plus 4 times 9. 4 times 700, 4 times 7 is 28. And then you put however many zeros you ignored at the end. And 4 times 9 is 36. So the final answer for this is 2836. Now another way that we could do this one is to call 709 710 minus 1. So you would have done 4 times 710 minus 1. And then you might actually do 700 plus 10 minus 1. We are renaming 710 then. So then you have 4 times 700 plus 4 times 10 minus 4 times 1. So we have 2800 plus 40 minus 4. And again, we'd end up with the same answer. People's brains work differently, which is why I want to give you other options to do it, because perhaps that's the way your brain worked. In number 2, we're going to deal mostly with the commutative and associative properties. And what those are basically reordering numbers so that it's easier to add them in your head. So when I see this 3, I'm hoping that there's a 7 so that 3 and 7 make 10, because when I'm dealing with 5s and 10s, it's really easy to add in my head. So I'm going to put the 3 next to the 7, and then the 20 plus 5 over here. I can do that by the commutative property. Then I'm going to add 3 and 7 first, and I'm going to add 20 and 55 together. So I'm putting these in parentheses. There's still a plus sign in between. Parentheses are allowed by the associative property. I can group them in any way I want. So rather than doing 3 plus 7 plus 20 plus 55, I'm going to do 3 plus 7 is 10, plus 20 plus 55 is 75. And 10 plus 75 is 85. In number 3, again, we're reordering so that things work out nice and easy in our head. And when we're multiplying, again, it's nice to have things that end in 0. So I'm looking for 2 things that will multiply and give me a 10, a 20, a 100, something like that. So I see a 5 and a 2. I know if I multiply those together, I'll end up with 10. So I'm going to put those next to each other, and then I'll put 7 times 8 next to each other. So 5 times 2 is going to give me 10, and then I'm going to group the 7 times 8, because I know what that is offhand. That's just a regular math fact. So 5 times 2 is 10, 7 times 8 is 56, and the reason that I wanted to do them in that order rather than 5 times 2 times 7 times 8 is now 10 times 56 is super easy. All I do is take the 0 and put it at the end of 56, and I have 560. Number 4 is another distributive property. We're going to think of 46 in a different way. And then, again, there's several ways to do that. One way is to do it as the 10s plus the 1s. So 40 plus 6. And then we have 8 times 40 plus 8 times 6. 8 times 40 is just 8 times 4, which is 32, with a 0 at the end. And then 8 times 6 is 48. 320 plus 48 is 368. Another way that you could do that is you could say 46 was 50 minus 4. So you would have 8 times 50 minus 4. 8 times 50 minus 8 times 4. 8 times 50 is going to be 400. Minus 8 times 4 is 32, which again is 368. Different ways to get the same answer. It's always good to have several ways to get the same answer so that you can check your work. Number 5 is also a distributive property problem. We're going to think about 156 differently. And since I offhand know what 150 times 2 is, I would write it as 2 times 150 plus 6. So then I have 2 times 150 plus 2 times 6. 2 times 150 is 300. 2 times 6 is 12. So then my final answer would be 312. Oops, not 313. You could also break it up into 3 numbers in the parentheses. You could say 2 times 100 plus 50 plus 6. So breaking it up into each hundreds, tens, and ones. Then you'd have 2 times 100 plus 2 times 50 plus 2 times 6. 2 times 100 would be 200. Plus 2 times 50 is 100. Plus 2 times 6 is 12. 200 plus 100 is 300, plus 12 is 312. Again, multiple ways to get the same answer. Whichever way works best with your brain, stick with that. Number 6, we have a whole string of numbers being added together. So that's our clue to start looking for numbers that complement each other, which means they add to 10 or 20 or 30 or something that ends in a 0. So when I see 23, I'm going to match that up with something that has a 7. So I'll put 23 plus 7. Then I see 8, and I'm hoping there's something that ends in a 2, 12. Then I see 14, hoping there's a 6. There is. And then 5 can go at the end. So I'm going to do 23 plus 7 separate, from 8 plus 12, from 14 plus 16. And then 5 will just be at the end. 23 plus 7 is 30. 8 plus 12 is 20. 14 plus 6 is 20. And then plus 5. 30 plus 20 is 50, plus 20 is 70, plus 5 is 75. Some word problems now. There are 29 teams in the NBA. Each team can have a maximum of 12 healthy players plus 3 players on the injured reserve. Use the distributive property to find the maximum number of players who can be in the NBA. So we have 29 teams, and each of those teams can have 12 healthy players and 3 injured players. So we could just use the distributive property and do 29 times 12 plus 29 times 3, but 29 is not a very easy number to work with. So what I would do is I would do 12 plus 3 is 15, so I would have 29 times 15. Well, 15 is an easier number to work with than 29, so I would then turn 29 into the number that's in the parentheses. So I would say, all right, I'm going to have 15 out front, and I can reorder multiplication, remember, by the commutative property. And I'm going to think of 29 as being 30 minus 1. So 15 times 30, well, that's 15 times 3. So 15, 30, 45 with a 0 at the end, and then minus 15. And then that's 435 players. The other way that you could have done that is to have done 15, and then instead of 29 being 30 minus 1, you could do 20 plus 9. So 15 times 20 plus 15 times 9. So 15 times 20 is 300. And then 15 times 9, you could break up as 10 times 9 is 90, and 5 times 9 is 45. So I have 90 and 45 is 135. And that's 435 players again. Same answer, different ways of getting it. Utah Olympic Park, the site of the 2002 Olympic Winter Games, gets an average of 295 inches of snowfall each year. About how much total snowfall would Utah Olympic Park get over a 5-year period? So we have a 5-year period times 295 inches of snow per year. So we can think about this again in several different ways. We could break it up into the hundreds, tens, and ones. So I could say 5 times 200 plus 90 plus 5. So 5 times 200 plus 5 times 90 plus 5 times 5. So 5 times 200 is 10 with 2 zeros. 5 times 90 is 45 with 1 zero. 5 times 5 is 25. So then we have 1,475 inches of snow. Another way we could have done it is 5 times 295. We could have thought of 295 as 300 minus 5. 5 times 300 minus 5 times 5. 5 times 300 is 15 with 2 zeros. Minus 5 times 5 is 25. So 500 minus 25 is 475. So 1,475 inches. Two different ways of getting the same answer. All right. And then number 9, how many hours are in a week? 24 hours are in a day, and there's 7 days a week. So we're going to multiply those two numbers. 24 times 7. And we'll break up the 24. So we have 20 plus 4 times 7. And the number can be on the back or the front for the distributive property. So we still have 20 times 7 plus 4 times 7. 2 times 7 is 14, so 20 times 7 is 140. 4 times 7 is 28. So there are 168 hours in a week. Another way that you could have done this problem is to work with the 24 being a 25. So we could have 7 times 24. Think of it as 7 times 25 minus 1. 7 times 25, well, there's 4 25s in 100, so it must be 175. And then 7 times 1 is 7. 175 minus 7 is 168. Write in the extra work there that I skipped in case you got lost. And the home stretch, so we have 2 times 438, another distributive property problem. So we have 2 times 400 plus 30 plus 8. So 2 times 400 plus 2 times 30 plus 2 times 8 is 800 plus 60 plus 16. So we have 876. And we could also do it as 440 minus 2. So we could do 2 times 440 minus 2. So then it would be 2 times 440 would be 880 minus 2 times 4 is 4, or that's 876 as well. In number 6, when you have a decimal, you can break it up as the whole number and the decimal. So we have 6 times 7 plus 0.5. 6 times 7 plus 6 times 0.5. 0.5 is just answering the question, what is half? It's asking the question, what is half of 6? So 6 times 7 is 42. 6 times 0.5, or what is half of 6, is 3. So our final answer would be 45 on that one. In number 12, we're looking to reorder so that it makes 10, 20, something that ends in 0. So when I see a 4 and a 25, I automatically think of a 100. So I'm going to write those next to each other. And then I'm going to do the 4 times 25 first, which is 100, times 15, which is basically 15, and then you stick the zeros at the end. Again, reordering in number 13, I see 3, so I'm looking for something that ends in 7. Put those next to each other. I see a 5, but I don't see another 5, so I'm going to save that one till the end. And then I see 9 and 1. Those add up to 10, so I'm going to put those next to each other. And I'll put the 5 at the end. I'm going to group the ones that add to 10s. 3 plus 7 is 10. 9 plus 1 is 10. Plus 5. 10 plus 10 plus 5 is 25. Just like in number 12 and number 14, I see a 25 and a 4. So that's kind of convenient. I'm going to put those next to each other, because that'll make 100, and then I'll have 7 times 5 next to each other. I'll do the 7 times 5, because that's pretty easy to do. And then the 25 times 4 is 100. 7 times 5 is 35. 35 times 100 is just 35, with the 2 zeros at the end. And number 15, we're reordering again. So something that ends in a 4, I'm going to pair up with something that ends in a 6. something that ends in 2, I'll pair up with something that ends in an 8. And again, the 5 is just left over, but that's not hard to deal with in the end. 14 and 6 is 20. 8 and 32 is 40. 20 plus 40 plus 5 is 65. The bonus problem, just like in number 11, when we broke up the number and the decimal, we'll break up the number and the fraction. So 16 and then 2 plus 1/4. So we have 16 times 2 plus 16 times 1/4. 16 times 2 is 32. And when you multiply a number by a fraction and the numerator is a 1, what it really is meaning is dividing by that denominator. So I could write 16 times 1/4 as 16 divided by 4, which is 4. So 32 plus 4 is 36. And the last one, you have a big long string of numbers and something being multiplied by 0. Well, by the multiplicative property of 0, anything times 0 is 0. So it doesn't matter what all the other numbers are, because it's being multiplied by 0 in the middle, the entire thing is 0.